Okay, if you guys will, let's go ahead and you guys can get out your PowerPoint over the endocrine system. And I would also like for you guys to turn in your book to page 269 and follow along with me. This first section is a little shorter. The next section, 8.2, is longer. But if you guys noticed on your weekly paper this week, you'll be able to use notes and the book on the test on Friday. But it would still be a good idea to make sure that make sure you work hard on your work this week so you kind of have an idea of where to find everything, and we'll do that. I just don't want to split this up. It keeps getting pushed back because of these snow days, and so I just don't want this to be lingering over us. I want to start fresh and new after spring break. So endocrine system, got three kind of major sections we'll talk about today: anatomy, a little bit, hormones, and then how hormones are secreted. Okay, so endocrine glands and exocrine glands. Endo, remember, means inside. So literally, crine at the end of that word means to secrete. So this one literally means to secrete within. Okay, versus exocrine. Exo is on the outside. So secrete on the outside. So we are specifically going to look at endocrine glands. We've already talked about a lot of exocrine glands when we did the skin. So endocrine glands do not have ducts. What that means is that the organ itself secretes the hormone, so it just kind of seeps out of it, I guess, if you will, and it moves directly into the bloodstream. So no ducts. Of course, it uses hormones, and hormones are just chemical messengers. Okay, they're just chemicals that are secreted that move to a target tissue, a specific area in the body, and kind of tell it what to do. Exocrine glands do secrete through a duct. So some examples of some that we've talked about: we have sweat glands, salivary glands, mammary glands, so the milk glands, lacrimal glands that produce tears, like we just talked about. And then the pancreas actually is also both an endocrine and exocrine gland. The reason that is it's an endocrine gland because it secretes insulin, it helps keep our blood sugar levels down. But it's also an exocrine gland because it produces digestive enzymes that get secreted directly into the small intestine. It helps to break down food and get it ready for absorption. Of course, endocrine is where we'll be. So some processes specifically that are affected by the endocrine system that we know of: carbohydrate, fat, and protein metabolism, so how our body is able to use those nutrients. Water and electrolyte balance is all hormone controlled. Reproductive activity, of course, is hormone controlled. Growth and development is all produced, we have growth hormone. So that's something else. And then, of course, responses to infection and stress can also be hormone related, as well as our energy balance, like our, just our ability to get up and go and sleep and that kind of thing. So all those are examples of processes that are affected by the endocrine system. Okay, different types of hormones. We have two basic types of hormones. We have steroid hormones. These are lipid-based, or fat-based, and then amino acid hormones that are protein-based. Most of our hormones are amino acid or protein-based, but we do have some that are steroid, specifically ones that come from what we call the adrenal cortex. And then reproductive hormones, those are our steroid hormones. And we'll talk specifically about those later on. Both of them we'll specifically talk about later on too. Amino acid hormones, of course, are protein-based, and most of them are those. The other thing to know about these is, we'll get to that in a second. Okay, hormone receptors. So when you think of a hormone, it's a chemical messenger in our body. Every hormone has a very specific place in the body that it moves to function, or that's what we know as its target cells or its target organ. Okay, so its target is just the where that chemical message goes. Okay, and it only affects that one area. Now, there's some hormones that have multiple targets. Okay, and that happens, but it only can affect the organs or the cells that it's supposed to affect that have receptors for that specific hormone. So when a hormone binds to its specific receptor on a cell, okay, there's a few different ways that it can work. Excuse me. One way that a hormone can, whenever it binds to its receptor cell, that it can work is it can actually change the permeability of the plasma membrane, the cell membrane. It can make it more permeable or less permeable to other things around it. So that's one thing, one way that a hormone can work. A second way that a hormone can work is that it can increase or decrease the enzyme activity of that cell. Okay, so remember, enzymes work as catalysts. They will increase the metabolic activity, okay, or whatever activity is going on, increases the rate of the reaction. So these can increase or decrease the way that the enzymes work. Some hormones might increase protein synthesis. So it actually binds to the inside of the cell, the nucleus of the cell, and then causes a change in how the DNA and RNA is creating those proteins and can increase the amount of proteins being made. And then the fourth way that a hormone can bind to its receptor, the fourth way that it can change it is to stimulate the secretion activity. So it can make it secrete more of another hormone, for example. So those are some ways that hormones can work and function. Upregulated and downregulated, it refers to the sensitivity of a hormone. So that's something else that can be changed. How sensitive is a target tissue to a hormone? So upregulated means it's going to be increased in sensitivity. Downregulated means it's going to be decreased in sensitivity. Actually, I want to read real quick. Page 270 kind of explains that. I know it sounds a little bit confusing. So on 270, on the right-hand side of that page, right above the paragraph, right above where it says check your understanding, let's read that real quick. It says exercise, for example, upregulates insulin receptors, making them more sensitive to insulin, a hormone that promotes the uptake of glucose in body tissue. Insulin helps to bring down your glucose, so it makes your body absorb it more, brings it down in the bloodstream. Because exercise upregulates insulin receptors, less insulin is needed to promote glucose uptake in people who are physically active. So people who are physically active produce less insulin because, or they need it less because of their activity, like they're using it up, okay? So, however, it says obesity downregulates insulin receptors so that more insulin must be present to promote glucose uptake by cells. Hence the reason why you have people with type 2 diabetes. So obesity is a risk for type 2 diabetes, which is where they can't produce enough insulin that they actually need. These two glucose uptake scenarios have important implications for diabetics, again, particularly those who are overweight, like my example. One thing to know on specifically for these hormones is that steroid hormones, actually the receptor is in the cell's nucleus versus amino acid hormones where the receptor is on the cell membrane itself. Okay, hormone secretion control. So there's three basic ways that hormones are instructed, if you will, to secrete, or I guess organs are instructed to secrete their particular hormone. We have neural control, which is just like what it sounds. It's controlled by a nervous impulse, okay? It's neurally controlled. The brain tells it to release its hormone. So one example of a neurally controlled hormone is epinephrine, and norepinephrine is the counterpart to that, or not counterpart, but they actually work together. And these are released specifically during sympathetic nervous system activity. So like fight or flight, you know, we talked about that when we talked about the nervous system. So fight or flight kicks in. Epinephrine and norepinephrine are the hormones that are involved in that. They're the neurotransmitters, the one that give the message. So that's an example. Another way that organs or that hormones can be instructed to be released is hormonal control. So some hormones, their job is to tell other endocrine organs to release more hormones. So hormone control, you know, hormones tell other hormones to be released. So that's one example of that is, we'll look at it in a minute. Sometimes you hear of these referred to as, you'll hear the word tropic hormones, and you might write this down, but tropic hormones are hormones whose target receptor, target organ is other endocrine organs. So tropic hormones are hormones that tell organs to release more hormones. And that'll make sense in a minute. But when you hear that word tropic, that's what you got to think of. And then the last way that hormones can be instructed to be secreted is humoral control. So humoral, anytime you see that word humoral, I always think of like fluid, but think of blood. Okay, so humoral control means that we've got sensors basically that tell how much of a hormone is in the bloodstream. Do we have too much? Do we not have enough? So forth. So it's looking at the bloodstream itself and the amount of hormone in there. So that kind of explains, hopefully at least explains those three things. Now look at this real quick. I know this is kind of difficult to read maybe on your PowerPoint, but it's also on page 271 in your book. So this kind of gives you an idea of how this works. I mean, it really is like just a system or a factory almost of how our body functions. So we have the central nervous system, our brain tells what organs what to do. So we've got a couple different things. Mainly this goes down straight down to the hypothalamus. We've talked about the hypothalamus before, okay, but there's a couple places, other things going on here. The book kind of talks about the hypothalamus as being like the president of our endocrine system. It kind of makes the decisions on everything else that's going on. So look, the hypothalamus has hormones that actually, it says hypothalamic hormones releasing factors. They actually moves over to the anterior pituitary. Okay, your pituitary gland, let me see if I can get to it. Okay, so this is the pituitary gland. This is kind of what it looks like. It actually is kind of like directly behind your nose or your nasal cavity, and you have an anterior portion and a posterior portion. Okay, we specifically, mostly will talk about the anterior. Go back to our, the anterior pituitary because it's got the most hormones, but posterior does as well. Anyway, so the hypothalamus sends message to the anterior pituitary and tells it what hormones then to release. And then from there, it has target organs. So like this one, for example, this ACTH is the adrenocorticotropic hormone. You notice that word tropic means it's going to tell the organ to release another hormone. So it releases adrenocorticotropic hormone that goes to the adrenal cortex, and then the adrenal cortex would then release these specific hormones that have some specific target organs of their own. Okay, another example is this one, thyroid stimulating hormone. So it stimulates the thyroid then to release its hormones. T3, T4, calcitonin, those are hormones that the thyroid releases. Okay, same thing, follicular stimulating hormone, luteinizing hormone. These both go to the ovaries and testes, so forth. So this is kind of its setup, okay, if you will. It's like the hypothalamus tells the anterior pituitary what to do, and then you've got it releases hormones that go to different organs. Now the hypothalamus is also connected to the posterior pituitary, and it has its own hormones that it releases, but these directly act on the organs, its target organs itself. Now the only other area on here we see that we haven't talked about is the central nervous system. The brain directly affects the adrenal medulla, which is the outer edges of the adrenal gland, and then it has epinephrine and norepinephrine, which we just talked about. Fight or flights, when your body kicks into fight or flight, epinephrine, norepinephrine is what makes your pupils dilate, your heart rate increase, so forth. But anyway, so look right here. It says note at the pancreas, which is a manager level hormone right down here, or a manager level gland, is stimulated or inhibited by blood glucose levels rather than signals from the CNS or other glands. So this would be an example of a humoral control, okay, because it's controlled by blood levels. Okay, these would be examples of hormonal control. Same with these because they're coming from a hormone up here. So, and then of course you have your neural control, which is going to be your hypothalamus, and then this is also neural because it directly comes from the central nervous system. Okay. Now, typically hormones work by negative feedback mechanisms, and we've talked about these a lot. We talked about at the very beginning of the year. Same way as like a thermostat type of idea. So when we have too much, kicks it off. We don't have enough, kicks it on. Okay, so the way that this one kind of functions, if you actually look at it in your book, it says this is a negative feedback loop. Number one, it says the hypothalamus and the pituitary gland direct the target gland to release its hormone. So hypothalamus releases a hormone, stimulates anterior pituitary, which then sends a hormone to the target gland, let's say thyroid, for example. I mean, that could be one example of a target gland, and then tells it to release its hormone depending on what the issue is. Okay, once that hormone is released, then number two, it says the target gland releases hormones to achieve the goal, whatever it needs, such as the stimulation of the tissues. After that occurs, then it says after the goal is achieved, so after we have enough of that hormone in the system, the target gland sends signals to the hypothalamus, pituitary, tells it to slow down the flow. We don't need to keep going with this. And so in turn, the hypothalamus also tells it, the pituitary gland, to slow down, inhibits it from doing its job. So that's how they work. I mean, it's constantly, checking levels. Do we need more of this? Do we not need more of this? I mean, this is a constant system that's working. Last one on here, the hypothalamus. Okay, like I said, it's kind of like the president, if you will, of the endocrine system. We'll talk about that specific. We just talked about it actually in the nervous system. But we know one of the other things it does is it regulates temperature. Okay, same way in here. So we have normal body temperature. So look, so if the body temperature rises above normal, then the sympathetic nervous system is stimulated by the hypothalamus. Blood vessels in the skin dilate to release heat into the atmosphere, to the air, and sweat glands are activated to cool off the skin. And so we lose body heat, and the body temperature starts dropping. Okay, if the body temperature goes too low, drops below normal, then the sympathetic nervous system is also stimulated, but it's going to do something different this time. This time, instead of dilating the blood vessels, we're going to constrict the blood vessels, and it's going to cause us to shiver. Okay, it's going to cause muscle contraction to shiver to increase heat production. So we keep that heat, goes back to normal. It's constantly, our body's constantly undergoing this regulation. And that's what the endocrine system does. It keeps our body in homeostasis. It makes our body function the way that it needs to. Okay, and that's that for section 1.